Hi, and welcome to MnRI Arduino Gadgets. This is a series of videos where I'm going to show you how to build useful, interesting, or fun gadgets with the parts that you'll find in a simple Arduino kit, but we're going to do some stuff that you might not find in those basic beginner's tutorials. So I'm going to assume you know how to do some basic things, like put the code for a gadget onto your Arduino, and how to put electronics onto a breadboard. If you aren't familiar with those things, there are some great tutorials online that we'll have links to, so you can get that basic knowledge down before you try to build this. What we're building today is a nice little calculator which supports addition and subtraction, but has the electronics to easily support multiplication and division in the future, even though that's a bit more coding. So this calculator supports addition, subtraction, multiplication, and division. Sorry, let me rephrase that, let me redo that, because it supports addition and subtraction, but not multiplication and division. So let me show you how to use this. We've got the number buttons here. You press these, a number is going to appear on the LCD screen. This A button here is for addition. The B button is conveniently enough for subtraction. It means nothing. And then C does multiplication, D would do division, but neither of these are supported right now. So if you put them in, it's either going to error out or just do nothing. We also have this button here, which clears everything, and then this button's the equals button. So let me show you how addition works. Let's try the simplest thing. 1 plus 1 equals 2. Great. Clear that. Now let's say 4 plus 5 equals, we get 9. And lastly, 4,578 plus 349. Apparently that equals 4,927. Look it up, see if it's right. I don't know. It should be right. Subtraction also works just fine. So 1 minus 5 will get us -4. Clear that. 44 minus 2 will get us 42. But like I said, the multiplication and division do not work. So they're going to give you weird answers. They'll probably give you just the first number that you type in. Yeah, okay. So that's everything. Now if you do make a mistake when you're typing in something, like say you put 2 plus signs, just hit the clear and you should be good. And yeah, I think that's everything. So this one's pretty straightforward with the wiring, but it is a lot of wires. We're actually using every single digital pin on the Arduino. So we're gonna get started. First off, I've got the keypad stuck to my breadboard with some sticky tack, just because it's kind of a pain, otherwise it shifts around a lot. And I have the back wiring stuck as well there. On the thing here, there's a little marker that shows which wire is 1 and which wire is 8. So for the membrane 4x4 keypad, there's 8 pins, and there's a little marker on the connector that shows you which pin is 1 and which one is 8. So make sure you pay attention to that when you're wiring it. All right, so let's get started on wiring this monstrosity. First, let's do a power and ground rail. So 5 volt and ground on the Arduino to 5 volt, or to power and ground on the breadboard. Now we need to connect with the LCD. Now I've done this a number of times. So let's just plug this in. Nice spot, good. All right, so first things first. We need to connect VSS, first pin, to ground. So we'll do that with a nice little black wire there. Now VDD goes to power, the red wire. Next, we have to add the potentiometer. This is the brightness controller. So the potentiometer has these 3 prongs. So these 2 go to power and ground, and this one is the output. So I'll put it kind of bridged over the side here. So there's the power and ground are attached to rails on this side, and the output's attached to a rail here on this side. So for the potentiometer, we'll put power and ground into the power and ground rails. It does not matter which one is which, actually. The potentiometer can be wired either way with no worries. And then we'll take the output of the potentiometer and connect it to V0 and this will control the brightness of our LCD. Very important to do. All right, next, the RS pin gets connected to pin 0 on the Arduino. The next thing, which is the read-write pin, that just goes to ground because we're not actually going to use it. Okay, now our E pin, the enable pin, to digital pin 1 on the Arduino. Okay, that's most of our LCD done. Now we have to do data pins 4 through 7. So D4 goes to pin 2, D5 goes to pin 3, D6 goes to pin 4, should be, pin 4, and D7 goes to pin 5. Now remember, with all this stuff, you can change which pins anything goes to. You need to change that in the code, but if you have stuff that doesn't work, or if you can't get your wires to a certain place, then you can always change it up. Okay, last pins for the LCD, the A and K. A goes to power, K goes to ground. So that should be our LCD all figured up. So we've got everything plugged in nicely there. Now I'm going to plug it in real quick and make sure that everything appears to be working, because this is very easy to mess up. I'll play with my potentiometer there. Okay, working great. Okay, now the tricky part. Well, it's more just a lot of cables part, really. Is the 4x4 membrane here. So this has 8 pins, 1 for each row and 1 for each column. So there's 1 pin per column, 1 pin per row. Now, pins 8 through 5, which should be, let me double check. Yeah, the way I have this, pins 8 through 5 are on the left side of the connector here, are the row pins, and pins 4 through 1 are the column pins. So I have orange wires for the column pins and yellow wires for the row pins. So this is going to go as follows. Pin 8 is going to go to digital pin 6 on the Arduino. Be real great if I was ambidextrous. Pin 2, or sorry, that's pin 7. We're kind of going backwards. Pin 7 goes to pin 7. Pin 6 is going to go to pin 8. And pin 5 is going to go to pin 9 on the Arduino. Let's make sure everything's plugged in there. And now it's time for the row pin, sorry, the column pins. Those were the row pins. So I'm going to start with these, I'm going to do them by batch. I'm going to plug in all of the orange column pins. So this is pins 4, 3, 2, and 1 on the membrane keypad. Geez, these don't want to go in. Something you might find trouble with, I have trouble with these at least, is that they might get a little stuck. Okay, so we got all those pins. Now, those are going to go pin 4 to pin 10, pin 5, or sorry, pin 3 to pin 11, pin 2 to pin 12, pin 1 to 13. So 8 to 6, 7 to 7, 6 to 8, 5 to 9, 4 to 10, 3 to 11, 2 to 12, 1 to 13. So there, we've got everything in order. all plugged up. All 13 digital pins used. So you can cross that off your bucket list. And to test this, you're going to want to press something. I mean, basically, it's not a bad idea to press something in every row and every column and make sure that it all shows up. All right, let's try this. 4 plus 4 equals 8. 8 minus 4 equals 4. Okay, so that should be everything. If you want to try some interesting stuff in the programming, I've got a few cool ideas for you. So one thing is that currently, when you're typing on the keypad, the text comes in starting at the left side of the screen. You can try and shift it to the right, which is the way that most calculators display things. Text comes on slowly from the right. Another thing to do is currently, every addition and subtraction that you do with this are separate. So if I add 2 plus 2, hit the equals button, and I get 4, I can't then hit plus 2 to get 6. You could try to make the result of every addition and subtraction a term in the equation for the next thing. That's pretty straightforward. A much more complicated thing would be to add support for the multiplication and division part of things. They're already all set up on the keypad in the code. The keypad already generates the correct characters for them, but for you to make them work, it's going to require a fair bit of programming. So if you want a challenge and you want to basically get your hands on kind of a very rudimentary compiler writing project, adding multiplication and division to this could be a really great thing to do. I think that's it. So I hope you enjoyed the video. Keep building new things, staying creative, and I'll see you sometime soon.